Now let's look at STT in the same kind of fine detail. And we talked about STT previously. STT, and this is going to be for, it doesn't matter what level it is, right? It's all levels of the spinal cord. STT is just STT. And STT, first order neuron, sitting here in the dorsal root ganglia. And the dendrites, what did the dendrites for STT carry? Does anybody remember? Yes.
Pain and temperature.
Awesome. So STT is going to be crude touch, pain, and temperature. Very primitive system. First order neuron coming in. Actually, synapses immediately in the dorsal gray horn. Here's your first order neuron. Synapses immediately in the dorsal gray horn with the second order neuron. And there's one thing you should know is that that second order neuron resides in a space with a special name, and I'm just going to draw the area approximately representing the space where that second order neuron resides. And this is where second order neurons for all STT reside. In this space, this special place is called substantia gelatinosa. Sounds like something Hermione Granger is saying while she's waving her wand, right? Substantia gelatinosa. Yeah, S-U-B-S-T-A-N-C-I-A. Too fast?
Way
Okay.
quarter speed.
Let me, I'll do better if I'm reading it. I can spell it, but I can't write and spell it. So S-U-B-S-T-A-N-C-I-A, substantia. Kind of like substance with an E at the end. Substantia.
What's the second word?
Gelatinosa. So like gelatin. G-E-L-A-T-I-N-O-S-A. So gelatinosa. Substantia gelatinosa. And that just is nothing more than the space in the dorsal root, in the dorsal gray horn, where the second order neurons involved in STT transmission reside. Okay? And this is going to be your, here's your second order neuron. Okay? Now, does anybody remember, well, we talked about it a little bit. So if I had to demarcate the difference between the lateral border and the anterior border of the spinal cord compartments, remember that STT tract is going to reside kind of crossing over anterior into lateral on both sides. And this is just STT tract. Yeah, yeah. So I'm trying to make it green. Yeah. Okay. It's all green. Yeah. My lighter, darker green one tint isn't working, so I switched to a lighter color green. But that should all. I'm just doing green. Okay. So second order neuron, because it's a second order neuron, decussates. So it sends out an axon. It comes down, crosses out here, and then hits its tract, and then starts to go up. Okay, so information, so this is right and this is left. So information from the left side of the body at the level of the spinal cord comes in and then immediately crosses over. So it's transmitted to the right side of the body right away, travels up the spinothalamic tract, and as I mentioned previously, every time there's a decussation, it's called something. this decussation here is known as the anterior, because it's anterior, white myelinated axons. So anterior white commissure, C-O-M-M-I-S-U-R-E. And the anterior white commissure is nothing more than the second order neurons' axons cross over in the spinal cord at each individual level. Anterior white commissure. Okay, like I said, this one's pretty straightforward. Nothing too tricky. You come in, you synapse in the area substantia gelatinosa, second order neuron sends out an axon, crosses over at the anterior white commissure, hits the spinal thalamic tract, and then just travels on up the spinal cord. Okay, and what I've done here is on the same page I was able to put the brain stem. So here's my midbrain, my pons, and my medulla. Right, there's my third cranial nerve. And there's my cerebral aqueduct. So the STT travels all the way up the spinal cord here, goes through the medulla, stays on that opposite side, and travels all the way up through the level of the midbrain. Okay, all the hard stuff's already done. Now, like I said before, what I'm going to do is we're going to switch over to the third order neuron. We'll come back to this one in just 1 minute, but for right now, the third order neuron here, this is the same view that we saw before, where here's my third cranial nerve. There's my midbrain. We had talked before that these were the basal ganglia. We'll talk about them later. Here's my thalamus. As well as ventricles, so lateral ventricles, third ventricle, cerebral aqueduct. Okay, everybody see where we are? Oh, we did. Coming off the other picture, that spinal thalamic tract is just going to travel all the way up through the midbrain. It's going to synapse here in the thalamus on a third order neuron. I'll label this as my spinal thalamic tract. That third order neuron, again, is going to reside in the ventral posterior lateral region of the thalamus. Okay, same as ECML, both STT and ECML synapse with third order neurons that are located in the ventral posterior lateral region of the thalamus. And both of these will also go through this space that we talked about before. This is your internal capsule. We're also going to draw in and make some other connections here. Way back when I talked about this white matter structure that was involved in crossing over or transmitting information from one side of the brain to the other. White matter structure, does anybody remember that one? Yeah, that's your corpus callosum. Good. Major decussation. Okay, and then on top of way back when, I talked about a special kind of gyrus that was part of the limbic system. I'm gonna draw just individual gyri, one for each side. So here's one gyrus, Here's the other gyrus. Does anybody remember the part of the gyrus that's involved in the limbic system? Cingulate. Yeah, that's your cingulate gyrus. Cingulate gyrus. And does anybody know anything about the limbic system? I like to think of the limbic system as the thing that moves you. Somebody was saying something? Yeah? No? Yeah, memory, motivation, olfaction, visceral, and emotion is the E. It moves you. So there's an E involved. So it has to do with emotion. Okay? So this is your cingulate gyrus. Okay, one on each side. Okay. So that third order neuron from the BPL of the thalamus sends out an axon, travels through this internal capsule, comes all the way up and makes a connection up here with the somatosensory cortex. But there's also an axon that branches off and makes a connection here at synapses with the cingulate gyrus. Anybody have any idea why that would happen? It's involved in emotion, yeah? Ellie?
It makes you feel bad?
Yeah, pain, it triggers emotions, right? I mean, so crying, you know, all that goes along with being in pain. I remember when my daughter was really little, she came home one day and said, "Mommy, somebody kicked a soccer ball and hit me in the head really hard with it, and I didn't even cry." I was like, well, good for you. But, you know, that's why, right? You'd expect her to cry because it hurt really bad. Pain causes emotion, right? That's one connection. The other really cool thing that happens is here's that there's another axon that comes out here and travels way back down. Now I'm going to travel back down through the midbrain again. I'm going to go back to this beginning drawing. Okay, and then there's an axon that's coming down here, comes down to the level of the medulla, and synapses with this structure here that we talked about that was involved in awareness, awakeness, regulating sleep-wake cycles, all that good stuff. That's your reticular formation. The red nucleus is up there. This is your reticular formation, and that's involved. I mean, if you want to think about sleep-wake cycles, awareness, consciousness, awakeness, that's your reticular formation. Yes, and that's another way to think about it. But also with the reticular formation, why do you think that the STT would make contact with the reticular formation? Anybody ever been in really super bad pain before? Broken a bone? That sort of thing? How'd you sleep that night? Not so good, right? So that's why. Because the spinothalamic tract actually comes back down and makes sure that if you're in really bad pain, you're going to stay awake, figure out what's going on. Okay? And if you've ever been in really bad pain, it's really hard to sleep because the reticular formation won't shut down. That's your seat of sleep-wake awareness consciousness. I always thought it was really cool. So two big connections STT makes with cingulate gyrus as well as the reticular formation. Yes?
And cingulate gyrus, the MOVE acronym was motivation, olfaction, emotion. What was
Memory, motivation. Memory and motivation go together. Their M stands for both memory and motivation. So it moves you, motivates you. It's also involved in memory, olfaction, visceral sensation, as well as emotion. And we'll talk more about that next year when we get to neurorehab. That's kind of I'm big on the limbic system. Okay, any questions about, yes?
Oh, sorry, just back on.
That's fine.
Is that one of the reasons why like smell is so strongly associated with memory?
No, smell's the only one that doesn't go through the thalamus. It has its own special processing area. So it's very different than anything. Yeah?
What did you say after olfaction?
Visceral.
Visceral?
Visceral sensation. Visceral. Yeah, that's what you don't you can, it's fine. Yeah, the limbic system moves you. Big time. Really important for motivation. Okay, the last little bit again. Let's look at just a big overview of the spinal thalamic tract and draw in all the players. Okay, so we talked before. I always like to draw my dots in so I know where I've crossed over. Drawing in big pieces that we drew in at the end. So here's my corpus callosum, white matter decussation. Okay. On top of the corpus callosum, I have my cingulate gyri. Okay, the other thing I ended up drawing in there is at the level of the medulla is my reticular formation. Okay. So, corpus callosum. Reticular formation. And this is my cingulate gyrus. Okay. So STT, really simple. This is going to be the right side of the body, and this is going to be the left side of the body. STT has first order neuron sitting out here in the dorsal root ganglia. It's going to pick up information about crude touch, pain, and temperature. Axon's going to synapse immediately. And down. Yes, thank you. It's going to synapse immediately in the dorsal right horn in the area of the substantia gelatinosa, the second order neuron. Okay. That second order neuron is going to send out axons that decussate. That decussation is called an anterior white commissure. It's going to travel up the spinal cord as the spinal thalamic tract, going through the medulla, the pons, to the midbrain, and a synapse here in the VPL, the thalamus, with the third order neuron. That's just their spinal thalamic tract. Okay. That third order neuron is then going to send out axons that go up here to the somatosensory cortex, also make contact with the cingulate gyrus, and also descend back down the spinal cord, make contact with the reticular formation. Yes?
Where's the nucleus?
It's in the substantia gelatinosa, in the area of the substantia gelatinosa.
Oh, so that's like.
It's in the. It's in the. It's in, no. It's in the dorsal gray horn. It's in the dorsal gray horn of the spinal cord. The second motor neuron resides in the dorsal gray horn of the spinal cord in the area that's known as substantia gelatinosa. Sorry?
That's the gracilis, the fasciculus gracilis.
That's a signal what? I can't hear you. Just say it louder.
The fasciculus gracilis, that's that one?
Fasciculus gracilis is DCML. This is STT. Spinal thalamic tract. DCML resides in the dorsal columns. Spinal thalamic tract is anterolateral. This is spinal thalamic tract here. Dorsal column. Alright, so the DCML system uses fasciculus gracilis and cuneatus. STT is spinal thalamic tract. Got it? Anybody else? Any other questions? Got it? Okay. And that's STT in a nutshell. With the last little one is really simple, and then we also have a clinical correlation to do some group work, which I think is important. You guys have learned already your dermatomes? Yes? Yeah? Perfect. Good. Then this will be easy. So, if I had to say, this is my rendition of Zebra Man. So which dermatome am I coloring in blue here? Yep, that's C5. That's C5. Okay, we'll make that. And let's go ahead and make next one down here. Which one's this one in green? That's C6. Okay, let's make C7. It's going to be here. Okay, let's make C8. Better? Thanks. That's C8. And the last one's going to be T1. It's going to be T1. And these are the same bilaterally. I'm just choosing to color in one side. It's a quick review. And in this program, they've adopted testing points for each of the dermatomes. You'll learn how to test dermatomes in CP3 next semester. Okay, but they've adopted specific areas to test for these dermatomes. And I'm just going to indicate that by a star. So for C5, you're going to test here. Okay. For C6, you're going to test here. C7 is there. It's coming through, okay. Okay. C8 is here. Okay. And T1 is here. So all I've done is I've just put a little star in the area where if you're testing someone's dermatomes for intact sensation, that's where you would test. And you'll learn how to do that next semester. That's beyond the scope of this course for sure. Okay? So C5 all the way down. 6, 7, 8, T1. Questions? Yes, Anna?
C7, that's middle finger?
That's middle finger. Yep.
No, that's okay. I just assumed it was.
Any other questions? There are lots of renditions of Zebra Man. This is just one of them. But in general, you should know where to test and like approximate what part of the arm your dermatomes reside in. And then you have lower extremity dermatomes, kind of the same thing. Okay, lower extremity Zebra Man. Let's go. Label this side. You guys can see that? Yep. Okay. This is going to be L2. Kind of like that aqua color. Let's make L3 nice red. Okay. I'm gonna go more medial for L4. Be highly contrasting. Oh, let's make it this. No. Maybe this one. Okay. Let's do L5 here. S1, I'll use orange here. And hopefully this is just a review. And what you're not going to be able to see, for S2, it's just going to be posterior medial thigh. So I'm just going to put this arrow here because you'd have to see the posterior. So S2 is going to be posterior medial thigh. And then testing these dermatomes, they would like you to test for L2 here. L3 here. L4 here, medial Ellis. L5 S1 and S2 is just posterior medial thigh. Questions? Is that pretty? Yes, Yep.
Is the L5 one of the toes?
No, it's actually the just below the web space of the second and third toe. It's just it's below. It's on the dorsum of the foot. It's not on a toe. Okay. And like I said, you'll get this in CP3. This is just in general. This is where these dermatomes reside. Any other questions? Okay, that's all the somatosensory.